The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.
Well, greetings and welcome along to the New Zealand Tech Podcast. I'm your host, Paul Spain, and today we are talking with Bruce Jackson, who's the founder at Kai's Education and 3D Printing Systems. Well, let's jump in. Bruce, maybe you can give a little bit of an introduction as to sort of where you fit into this big wild world of tech here in New Zealand.
Yeah, well, thanks for having us on board. And where did I start? I started pulling apart dot matrix printers and dial-up modems when I was a little kid. That got me into having an understanding of what tech is and, started coding and built my own disco. And, then I saw this thing, 11 years ago called a 3D printer. And I thought, this is going to be, hot as hot muffin, So I got onto that and purchased my first 3D printer. I didn't know what I was going to do with it. I didn't know what the market was. I thought, architects are going to love this. Had it wearing out stuff. I was just amazed by it. And I then took it over to a trade show in Melbourne, engineering show. And I started in a garage like most Kiwi businesses do. And within 1 month, I was in a warehouse. I was just selling these units like lollies and great, So, that's what been my journey. I've hacked my own car for self-driving. It kind of worked, So
that's great. Well, it sounds like there's going to be a lot we can chat about today. Before we sort of jump in too far, I just want to say a big thank you to our show partners, Vodafone, 2 Degrees, Spark, HP, and Gorilla Technology, not only for their support of the New Zealand Tech Podcast, but also broader tech and innovation ecosystems here in New Zealand. Let's get into that. You mentioned self-driving. That's always a thing that takes my interest. So we'll definitely be keen to have a chat around that. But the 3D printing seems to have sort of been a big part. And of course, now with Kai's Education, you've got your KaiBot, your sort of robotics and educational pieces for youngsters, which is, I guess, what we we'll really want to delve into today. But yeah, maybe we can hear a little bit more around the 3D printing and 3D scanning and what that business has evolved into over the last decade. 'Cause you still run that as well as doing Kai's Education.
Yeah, I've still got
right?
3D printing, and we sell most of our machines into Australia. We don't really focus too much on New Zealand, but we're a New Zealand company. Everything has started here, and
That's
we're
great.
still running here. So when I was pushing out these 3D printers, most of them were going into schools, and that certainly turned on a light bulb moment for me in seeing, learning about how education uses technology. And that put me down a journey on making, resources that schools could use. So instead of just having a 3D printer that's going to sit on a shelf and gather dust because they bought this cool toy, but how do they implement this into their curriculum? So that put me on this journey on let's make resources that they can use with their 3D printers to do that. And that's where I started with the robotics in education.
Yeah, good.
So then I started designing and using 3D scanning and using these tools myself to create product that is used in the classroom today, whether those are print your own little devices. We started with a print your own 3D scanner. So we sold the components that you use, and you had to have a 3D printer to print your own scanner. And now we use 3D printing and design to design our own products. We don't manufacture them here. I mean, it's cheaper to manufacture in China. That's got its own challenges. But having that prototyping to be able to 3D print something, to get the feel of it right away, within an hour or a couple of hours' time, and say, this doesn't really fit, or that component doesn't go, or there's a change in components because China can't supply that component anymore. you can adapt and really turn around a product much, much faster than we've ever been able to do.
Yeah, I think there's certainly specific areas where where 3D printing is just absolutely invaluable, and I guess there's all sorts of the technologies that we just take for granted in our organisations and businesses today. That if you suddenly turned off all the technology, it would be
We'd be all lost.
Yeah, be very 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 painful. And in terms of where you see 3D printing being the most valuable, is it that sort of manufacturing world, or are there other particular areas where where you see it's very very important today?
I think it's got, we've definitely come into like a mature, we've gone over the Gartner hype cycle of 3D printing, and it's definitely now a, mature platform. There is new innovation constantly coming out. There's 3D printing buildings. We'd have a lot of red tape to solve in New Zealand to do that, but there's the medical field. So there's so many fields, separate segments on the 3D printing industry. From my side of things, most business, like jet boat companies printing out their own, props and using old technology to cast them. So 3D print it, send it to the casting shop, and you've got a stainless steel boat prop, And I just love that convergence where we use old tech with new tech to get solutions made. But there is 3D printing in metal. I think that's definitely the holy grail. But it's not a simple thing. It's still very expensive to achieve metal prints.
Yeah, it was interesting. I was up at Sale GP Technologies. I've been, walk with, how long ago was it now? A little while back in the last 12, 18 months. And it was certainly very, very interesting to see the different technologies they were using there, and, what sort of quality that you can really get out of the different machines and 3D scanning, and you can see how within that high end world of sailing and racing and so on, just how useful that technology
definitely
is.
the adaptation and just being able to change stuff on the fly, and have a new type of product, whatever it is, to be able to. I mean, the biggest challenge on 3D scanning is that most people go, oh, I can just 3D scan this. Let's say I've got an old Ford 1968, Mustang or whatever, and I've got this component and it's broken or whatever. Can you just 3D scan it and print me one? With 3D scanning, it's not an X-ray machine, so we can't see internal geometry. So we've always got to 3D scan the external, and the internals need a lot of manual labor in certain CAD to redesign the internals to be able to then 3D print. So a part that might normally cost $100 is now costing several hundred because of labor costs to rejig the part.
And in terms of online databases of 3D items, how has that side come along? There seem to be lots of different options. Some's open source, other things you pay for, and so on. What does that landscape actually look
I think
like today?
the library's getting bigger and bigger, but I think when you talk to like a commercial company, for instance, we do a lot of companies doing ute modifications. Having a library of all the different vehicle types, all the chassis types in a ute, companies are holding that data to themselves because that's their value. So you don't
it's their
really,
intellectual property, isn't
yeah,
it? So
exactly.
whilst as a sort of an individual, company, you could go and scan something and make your own copy and probably get away with it. There's a level to which if you start distributing those scans online, you're probably going to get yourself into a bit of trouble.
Yeah, I think the biggest change that the 3D world is going to have is when we start introducing AI into being able to regenerate models. Give a 3D scan of something and it goes, oh, I recognize this. I estimate that this has got holes in it, and I estimate the thread size, and then it builds a 3D model for you. I think that is going to be a massive change in on the 3D engineering side of things.
Yeah, that'll make a lot of sense. Good use of AI. Now you talked about self-driving or autonomous vehicle tech. Are you one that's dabbled with Open Pilot? Is that the
That's right?
the
Yeah,
technology
yeah.
from Comma?
That's Comma AI. That's
Yeah,
right.
yeah,
Yeah. Fantastic with a bit of gear.
Yeah.
And I mean, and it works. It works, and it's easy to do. DBT port, and off you go.
So walk us through setting up your vehicle like this, because I've known others that have done it, but I haven't really delved too much into how much time does it take? Obviously, you've got to have a vehicle that's compatible, how good is it? I'm sure you probably compared it to Tesla.
I've compared it to
so on.
Tesla.
Yeah.
I mean, it's probably as good as the $10,000 Tesla, add-on. For, at the end of the day, a lot of these things are like line following.
You're following the lines on the road. If the road's well marked, then it's easy to follow, isn't it?
Road's well marked. And there are still, even if there's no markings on the road, there's still markings on the road in terms of, there's a gully on the road. That's still a constant line that computer vision can see. So they do still work quite well, even on a road that's got no markings. Tesla's got major failings in its current edition in New Zealand of its self-driving. In the US one, it looks brilliant.
Yeah,
it looks
amazing. Well, I'm currently having some discussions with them, shall we say, about my investment, because interestingly, when they launched the Model 3 here in New Zealand, and you could add on the FSD package, a little under 10K at that point in time. But they specifically put in writing what the features were that they were going to deliver in 2019, and actually they haven't delivered on the key one, which is what they call driving on city streets, which would get you from A to B. Sure, you're overseeing it and watching it, and we've seen all the videos of that in the US and beta. But what should have arrived within the first few months, according to what they put in black and white. For me, still hasn't arrived.
A lot of marketing
nearly
message
3.5 years later. So it's going to be interesting to see what comes of that discussion at the moment, or whether there will be some other legal hoops and disputes type processes to go through to work that out. I mean, this stuff is I think has proven to be harder to take to the next level probably than what many would have thought. But I find quite fascinating what Comma have done with Open Pilot and having this open source technology that has worked very well for a lot of people. I guess it's mostly sort of on the state highways, on the motorways, where you tend to use it.
Yeah, most definitely, and it's a good piece of kit. All of these things, you've got to have your hands ready at the wheel, whether it's a Tesla or anything, because a chicken crosses the road. None of these systems are capable of.
Well, the chicken's going to die, isn't it?
The chicken's going to die, but what do you do?
Yeah.
It's just a metaphor, but
there are unexpected things.
There are
aren't
unexpected. There's always the unexpected.
Yeah.
A bicycle, a scooter, a piece of metal flying off a truck. None of these systems are programmed to avoid that. There's not enough data to do that. You'd have to put a lot of metal off trucks to just train that particular scenario. What color is it? What angle? What size? There's just it's unlimited the possibilities to react for a vehicle to react to that. but they both do good jobs, in terms of, I would say the Comma AI and Tesla's $10,000 New Zealand version are pretty equivalent. I mean, the Tesla's reverse parking is atrocious. It just cannot reverse,
Yeah, it's a bit of a shocker, isn't it?
Yeah.
Yeah, and there obviously there's sort of competing things, Mercedes and others at varying points with some pretty good technologies. How does it handle road cones? Is it sort of capable on that front at this point, or is that it's not there yet?
It doesn't. Yeah. No, I mean, I wish there was a counter in some of these things to count how many road cones we have on these roads. That would always be a good. Oh, you've reached 1,000 road cones. Ding ding.
Yeah, I think that'd be a common day around some parts of the country. I have had situations with Tesla where it is a very good job with cones on a motorway, and then other times where it won't. One, I was on a journey, and the end was I think it was only Hunga exit the motorway in Auckland, and there were cones basically across and sort of merging you across into other lanes and so on. And this was a sort of an evening jaunt. Probably it might have been very soon after they turned on the what they call it, navigate on autopilot capabilities in New Zealand, and I thought I've got to try this. So, just went for a drive, and it handled it really well. And then another scenario was State Highway 1, heading from between Hamilton and Auckland, and vehicles sort of navigating through cones quite well. But it almost feels like it's lost some of those capabilities, because recently I had scenarios where I'm like, "Ooh, I'm going to be, I'm taking over," and
otherwise you're going to be eating cones for breakfast. Yeah,
that's exactly it. So it is quite fascinating to see these technologies.
I mean, I would love them to incorporate, pothole detection. A tricky one to do if it's raining,
and feed it back to the council, right?
Yeah, so there you go. That's a great idea.
Win-win. I'm sure. It's probably not the council that's responsible for those, but back to the relevant entities to come and sort it out. Sort things out. Great. Now, onto this world of robotics that you've got into and education. So walk us through that story with Kai's education. It's,
I mean, I was going back a bit. So I was doing these 3D printers. I was making curriculum 3D content, products, going into the classroom, and then I was going into the coding, some of the schools, and seeing what they were doing with coding, and the kids are just using their thumbs to drive around balls. And I'm like,
that's not coding.
That's not coding. And I'm like,
remote control cars.
Remote control cars with an education label. And I went to an open day, and there's 10 schools on display, and the same thing's happening. I'm like, come on, guys. Or there's little robots that are following a line. And
is education washing a term?
Yeah.
My son started playing this game called Geometry Dash. I don't know if you've come across it, but I saw the request come through. He wants to install this, and I'm thinking, that sounds good. That sounds very educational. Of course, I can approve that. And later I found out it's not a particularly educational game. Put it that way. So there's a lot of these things that kind of look a little bit educational, but is there that real learning opportunity?
Yeah. So I just got frustrated. My son was learning coding at that time, and I'm just going, we've got to make, and I started looking at all the products, and there's like a little bee thing robot that, is just going forward, left and right. And I'm like, how do you get to the ceiling of the current products very quickly? The maximum capability that you can learn from this device is like very restrictive. So I just researched the thing and I said, man, there's a huge open market. And for our first product, Kai's Clan, I said, you've got all these different technologies. You've got IoT, you've got AR, you've got VR. And I was like, why don't we make a tool that encompasses all of these tech? And because in business, we have, just like you've got microphones, you've got video, you've got streaming, you've got all different types of tech all connected together to produce one outcome. And that's what we started doing, and we put IoT in, so you can program this little yellow robot, this cute little yellow robot over the internet because it's an IoT device. And no one had done that in the education space that we could find. I'm like, so we kind of made something for COVID that we didn't even know happened. So that was a really good outcome when COVID hit. Teachers could have the robots at home and the kids could still be remoting and coding their robots over the internet because it's an IoT device. And then viewing the physical robot in a virtual instance on their computers. Because our speciality is merging the physical robot and a virtual kind of avatar with it. So wherever the physical robot moves, the virtual robot moves. And then they can do animations on the robot, get temperature data, real temperature data off a robot, and have that represented in the virtual, or make it rain in the virtual space based on humidity sensor data.
That's great. Yeah, I can see the educational, potential if you can make it, quite easy, is phenomenal. I think of some of the gadgets that we've sort of been sent and have, tested over the years across New Zealand Tech Podcast, and some of these are from very well funded, Silicon Valley or US startups that have had a whole lot of venture capital thrown into them. They come up with some gorgeous products. I remember one of the little sort of robots with a little sort of like a digger type thing on the front that would go around and do things, and it was very cute. And they had it was kind of some sort of modern slot car set, sort of racing
that's right,
car,
the Anki one,
type thing.
Yeah.
So there were Anki was a company I was thinking of, and they created what was some really nice products. Now they when the funding ran out. They hadn't really kind of landed on, how this technology should sort of fit into the market. And to me, it seems that education is the perfect place, because then you can tie together these reasonably low cost sort of gadgets to actually do things that are quite interesting and are educational. Because in terms of just kids playing with sort of some of that Anki equipment, I think they lose interest pretty quickly.
Yeah.
So if you can work it in so it can get used in the classroom, which seems to be the approach you've taken, I think you have a really, really big potential.
Yeah, thank you. Yeah, so definitely, what we found was all the products on the market were toys converted into an educational product. So we said, okay, let's, and we used teachers. Teachers came into our offices and go, hey, let's give you feedback, and this is how we do it. And our first iteration, we failed drastically. We're trying to do an IoT system on a school network. That's a recipe for disaster. But fantastic engineers. We've made a self-healing mesh network. So all the robots talk to themselves and choose a robot that's got the best battery power, and then communicate that through that. But the teacher doesn't see that. It's all behind the scenes. It's all automatic. So we definitely design for the classroom rather than design for the parent or that. Our new robot will definitely be available for the parent and the child, but it's not a toy. It's an educational tool to learn how to code and do many other things.
That's great. And who's behind the business? Is this sort of a bootstrap type thing? Have you got a lot of funding? what's been your approach from that perspective at this point?
Well, very fortunate with the 3D printing business. That's bootstrapped us to develop this. We've had no funding, no other funding outside. But we're ready for growth now. This is our second product that we've just finished off. 2,000 pre-production units being shipped out as we speak to countries like Italy, US, Aussie. Yeah.
And you've won an award recently?
Yeah, that was very lucky. Serial number 1 of a product. It's always a little bit touch and go when you send serial number 1 out for an award. But they really wanted us, to submit it because they loved what we showed them, our prototype. And we were like very nervous. And we got a phone call and said, yep, you're in the finalists. So they flew a colleague of ours out to Dubai, all expenses paid. And we're very lucky to win the award. We've had great help by, New Zealand
NZ Trade and Enterprise.
NZ Trade and Enterprise, as well as NZ EdTech. So, they've been behind us and they really helping us getting ready to grow significantly. Yeah.
That's great. So walk us through the new product.
So what we wanted to do is we wanted a product that can be used without any computer, because kids at the moment, kids through COVID have had way too much digital exposure. We got to...
Surely not. Is there a limit?
Is there a limit? We just got to get back into some of the physical computing devices. But how can you teach coding using physical computing? I was like, that's a challenge in itself. So what we have is we have a deck of cards, if you imagine a deck of cards, but these cards are constructed kind of like Python, so that there's over 100 cards. These cards are also available in Braille, so for the hard of sight. And you construct these cards out as if you were going to say code. So simply you would say move forward, turn left, right? Basic things. So you've got a start and a finish. We've got these square 15 centimeter magnetic tiles that snap together, so you can build out a level or like a maze that you'd lay out on the floor or on your desk, and you've got to get the robot from the start to the finish, right? So you go forward, left, forward, left, forward, left. Well, those things I've just done is actually a loop. So forward, left is one segment, but you're repeating that 3 times. So we say, okay, to the kids, add a loop card, a loop start and a loop end. How many times do you want to loop? So we've got this kind of construct for young kids or teachers who have never coded before, because we've got a lot of teachers who have been put into teaching computer science, but they've never been trained for it. So we lay out this construct, then we use the robot, we tap each card, we tap the robot onto the card. It's got a special camera that can recognize what the card is, taps, and you're programming the robot. Now,
fantastic. That's a great approach.
So if you say, I tap start record, start loop, and you don't put in how many times that you're going to loop, the robot's got a little screen on it, and it says, bug alert, you've left out, loop how many times.
Excellent.
So what this is doing is, because a lot of kids in a classroom are too scared to put up their hand, because putting up your hand is sometimes seen as, I'm failing, I don't know what to do, and I don't want to feel, awkward in front of the whole classroom. I mean, no one, you do a podcast or you do a live thing and you say, any questions? And people are always a little bit shy to put up their hands, and kids are the same. So if the robot can help the child find the fault that he's made, correct the mistake, and then he can just carry on coding and really give the child a lot of confidence to build up their coding, template.
Yeah, that's really neat. And how much have you been able to test so far with the new one and with different audiences?
Way too much. Way too much. Yeah, so having young kids who have never coded before use the product. When we're developing, we're constantly going into local schools and getting kids to test the product constantly, and we get the feedback and we improve on the product. And the product development cycle on this is like taken 2 years, which should have been a year, but it's taken 2 years. But we've really been able to fine tune and get it ready for the classroom. Along with that, we make a whole lot of lesson plans, and we get teachers from the US or from Australia to create lesson plans that wrap around the product. So you're not just getting a product; you're getting the activities or the projects with it.
Now, in tech, we've generally over recent decades at least ended up with a lot more guys coming through with tech interests and tech qualifications. Are you finding that this is sort of broad interest? Girls and boys are taking interest, and you've been able to develop it in such a way that you connect in both directions.
Yeah, definitely. I mean, when we designed it, we want it to be fully inclusive. I mean, you see the little robot here; it's got a little unicorn. Sleeve on it, little poop.
Right, so they
poop,
can be personalised up accordingly.
So the kids can make it their own. We've got blank sleeves that they can design and create for themselves. But we want the product, not boys, girls, just universal. So whether it's a teenager or a young child, we can use the product with them as well, and they don't feel out of place or. So it's just really inclusive on what we're doing.
Yeah, and in terms of the way that you sort of expect it to sort of evolve in the future with, I guess the different exercises that it can be used for. Would you expect that to cover what sort of age range you would see the interest?
So, I mean, we'll start from a 5-year-old child, probably the youngest, but we've got a virtual platform that runs on top of the physical. So that's our speciality again. We have the physical with the virtual. In the virtual, we have a maze builder, game level builder.
Yep.
So older kids can actually use our virtual only, so you can use it virtually only, called Conundrum, with a KAI as Kainundrum.
Yep.
.com, and you can go on there today and play for free, play and code for free. And you can build your own levels. So because we've got a level builder, you can really scope it out quite far. So you can go up to high school with it. In our virtual builder, there are things that we talked about earlier, self-driving cars. It's got a radar on it. The radar can sense objects. There's oil slicks, there's lasers, there's gates. If the physical robot hits a virtual gate that's closed, it stops. So if you code it to go through, if you've paired the robot with your iPad or your tablet, and you see there's a gate and you try and go through that gate, you can't go through, the physical robot can't go through a virtual gate. And there's balloons to pop and a lot of problem solving and getting kids, creative skills going on, not just solving levels, but also creating their own levels to then go and solve later.
Great. And you mentioned Minecraft at one point. There's some sort of crossover there with some of the software and so on you've been building?
Yeah, totally. So with our first generation robot, kids can create their own robot avatars. So that means they can go into Minecraft, they can create elements, graphic elements that we can use in our virtual, VR side of things for the robots. What this means is, let's say you've got a classroom, with a dozen kids in there, and they all go and create their own Minecraft characters. One wants to be a chicken, and that chicken again. And they can all be different characters. And then when you're coding your physical robot, you can then sit inside VR and you can see all these Minecraft characters, not in Minecraft itself, but in our own virtual apps and augmented apps as well, augmented reality apps. Yeah,
great. So where to next? You're really going out sort of globally, aren't you, in terms of launching your products and looking at the export opportunities?
Yeah, totally. We're definitely going to be ramping up. We're this time next week we're going to do 4 shows in 5 weeks in the US. We're going to freeze our butts off. It's like -10 in some places. But yeah, we're really ready to grow now. I think having our second product under our belt now, and we can really look at expanding. We've got a lot of associated products as well, so we don't currently offer any subscription. So from a business side of things, we've got quite a wide product portfolio, I feel, and we'll carry on innovating and developing new products. Yeah,
that's great. And how big's your team at this stage?
Oh, we're small. There's 9 of us in total. Some of that staff is shared from the 3D printing to the Kai's education. But yeah, we're ready to grow. We've got game developers on our team. We've got hardware engineers, designers. To put a physical product together as well as a virtual product takes, and networking and servers and all of that kind of stuff in the cloud. It takes quite a lot of resources to do that. It's not just a physical product.
Yeah, well, I mean that's great to have a sort of a end-to-end offering that's that's immediately useful for education.
Yeah.
So for those that are listening, whether they're parents that are interested in this sort of thing for their school, or teachers and so on, where should people go to look and find out what the options are? Is it reasonably easy at this point to sort of get started?
Yeah, I mean, our new product is going to be about 130 New Zealand dollars starting price, and yeah, kaiseducation.com. So KAI. Kaiseducation.com is where to go, and that's when they'll be able to order product from us. Yeah.
That's great. Well, Bruce Jackson, thank you very much for coming on the New Zealand Tech Podcast today. It's been fascinating, and certainly wish you all the best with Kai's Education, KaiBot, and the other parts of the ecosystem. And yeah, I really hope this is something that can be adopted across New Zealand, and that we get that sort of win on the education side and a win also on the export side. So that's fantastic.
Yeah, most thank you very much.
Well, thanks everyone for joining us on this episode of the New Zealand Tech Podcast. Of course, also thanks to our show partners, Vodafone, Spark, 2 Degrees, HP, and Gorilla Technology. And we'll be back again, of course, with another show next week. If you have been catching the video for this episode, would recommend go and fire up a podcast app on your smartphone, be that Apple Podcasts, Spotify, Google Podcasts, etc., and subscribe or follow the NZ Tech Podcast, which is free. Of course, if you're listening to the audio episode, you can catch the videos that most weeks tend to go out live on a Tuesday afternoon. And we're across LinkedIn. At this stage, the best thing on LinkedIn is to follow myself, Paul Spain, but you can also find NZ Tech Podcast across YouTube, Twitter, and Facebook. All right, thanks everyone. Catch you next week. See ya. Cheers, Bruce.
Thank you.
The New Zealand Tech Podcast, brought to you by Gorilla Technology, proactive and strategic IT.